Hi, welcome to lesson 18D on integration. So we've seen antiderivatives of x to the power 4 gives us 1 over 5 x to the power 5, or the antiderivative of x would be 1/2 x squared, or the antiderivative of x squared would give us 1/3 x cubed, etc. So what we're going to do is we're going to start looking at a few more some of the more important features of antiderivatives. So when we're looking at, say, a gradient of a tangent at any point, if there were a vertical translation of the function, that tangent would just stick to the function and the gradient wouldn't change at all. It would just get increased. It would just move up or translate vertically along with the function. So for an indefinite integral, the integral of x to the power 4, which is 1 over 5 x to the power 5, we add a c there because it can move up and down. It can be vertically shifted up or down some value c without actually changing the gradient, changing the value of it. So we can just add that in just to be a little bit more precise with our integration. So if we take the integral of x to the power 4 with respect to x, becomes 1 over 5 x to the power 5 plus c, and c is just some sort of constant. Okay, so here's an important thing that we're going to have to refer back to. If the derivative of capital F of x gives us f of x, some function, then the integral of that function f of x with respect to x is just the capital F of x plus c. Okay, so this is going to be our starting point. This is what we're going to use later on in this lesson. So because this is called an indefinite indefinite integration, because it's not being applied to any particular interval of x values. Okay, so just like limits and derivatives that involve constants, if we take the limit of 3x squared as x approaches 3, we can actually move this 3 out in front. So it's 3 times the limit of x squared as x approaches 3. Also, if we take the derivative of 4x to the power 5, it's the same as moving that 4 in front and taking the derivative of x to the power 5. That 5 would just move down and multiply by the 4 eventually anyways. So just like we can do those two things, what we can also do is we can move a constant for integral purposes out in front also. So if we've got the integral of 3x to the power 4 with respect to x, we can move the 3 to the front and then just take the integral of x to the power 4 with respect to x. So if we take the integral of this, 3x to the power 4 dx, then it becomes 3 over 5 x to the power 5, because if we were to increase this interval, or exponent by 1 to give you 5, which is what we do with integration, we also have to divide by that 5, because if we were then to take the derivative, the 5 would come down and the 5's would cancel to leave just with the 3x to the power 4. So we do that, and then we add the c, which is a constant. If we look at it in this way, when we take the 3 out front, the integral of x to the power 4 dx is 1 over 5 x to the power 5 plus c, and that 3 is still just out front here, that constant. If we were to multiply that 3 in, we would get 3 over 5 x to the power 5 plus c. Now that c doesn't have to be multiplied by 3 because it's just a general constant anyways. So whether there's a 3 out here or not, we can just leave that as c. It doesn't have to be 3c. Okay, so in your note it says c over 5 or something. Yeah, c over 5. We don't need that because that's incorrect. What I was trying to say is we don't have to write this as 3c, because just c will do. Alright, let's flip this over. And so here's just a couple of rules. So any constant in front of the function can be brought in front of the integral sign, and the integral of some sum of functions is just the sum of the integral of the two functions. Okay, so what we can do is we'll take a look at this example here, and so it asks us, so first of all it tells us if y equals 3x plus 2 all to the power 5, we want to find dy by dx. Okay, well we can do that. Hopefully you can identify that this would be a chain rule, so we bring the 5 down in front and subtract 1 from the exponent to give us 4, and then we go inside and take the derivative of the inside, and that would just give us 3. And then we take this 3, multiply by 5 to give us 15, 3x plus 2 to the power 4. Okay, so that is the derivative. Now after we find that, now it's asking us to find the integral of 3x plus 2 to the power 4 with respect to x. Well, we've got this 3x plus 2 to the power 4 here. We've also got the 15. But let's remember what we saw on the other side of the sheet, right here, that I started. If you take the derivative to find the function, and then you go ahead and take the integral of that function, you're going to get that original capital F function plus c. Okay, so if we can start with this format right here, we will say that the integral now of 15, 3x plus 2 to the power 4 dx. So this is the function we have, but we want to just take the integral of that function without the 15, so we'll deal with that in a second. So that's going to give us 3x plus 2 to the power 5 plus c. So this is that capital F of x plus c. So because we're just trying to find the integral of 3x plus 2 to the power 4, but we have a 15 here, what we're going to do is we're going to take this 15 outside. And that still just equals 3x plus 2 to the power 5 plus c. And then again, just to reiterate, we only want the 3x plus 2 to the power 4, but we've got that 15 here. So let's divide both sides by 15. So we get 3x plus 2 to the power 4 dx, which is what we were asked to find the integral of. And when we divide both sides by 15, we end up getting 1 over 15, 3x plus 2 to the power 5 plus c. Okay, again, we don't have to multiply this or divide this by 15 because it's just a constant anyways. So then, if we want to check this to make sure we get this 3x plus 2 to the power 4, when we multiply this 5 down in front, if we were to check this by taking the derivative, multiply the 5 down in front, we get 5 over 15, which can be reduced down to 1 over 3. 3x plus 2 all to the power 4, and then we go inside and take the derivative of 3x plus 2, which gives us 3, and that 3 times 1 over 3 just becomes 1, which is in front here. And then the derivative of a constant just becomes 0, which is why it's not over here. Okay, so that is the integral of 3x plus 2 to the power 4.